So in this video we will be covering empirical and molecular formulas in chemistry. So I'm just gonna go through calculating the empirical formula from a question. So the question is, the analysis of a compound gives us the following information. Oops, went right off the page. So this is the information we get from the chemical analysis. So we find out that the compound is made out of 21.9% sodium, 45.7% carbon, 1.9% hydrogen, and 30.5% oxygen and by mass. So by mass essentially means that if we had, say, 100 grams of this compound, we know that 21.9 grams is sodium, 45.7 grams is carbon, and so on. So this is what the by mass essentially describes. So there's one more piece of given information which I should write down. Actually the question is, determine the the molecular formula if the molar mass is 210 grams per mole. So when it says 210 grams per mole, it is the molar mass. It is the molar mass of the molecular formula. So that's what they're saying. So we have this information, and so what do we do next? Really easy. Your next step should be to sort of make up a small table. So it should be step 1. Always assume that you're dealing with 100 grams of sample. So if we know we're dealing with 100 grams of sample, we can easily say that for sodium, we're dealing with 21.9 grams, because it was 21.9%. For carbon, we are dealing with 45.7 grams. For hydrogen, 1.9 grams. And for oxygen, 30.5 grams. And again, it's not magic. I'm just getting these numbers right off from here. This is all by mass, so I just said assume 100 grams from here. And this is where I got the numbers from. So this is where I get the information from. I've got a little table set up over here. Right? So that's what you have right now. Your next step should be to calculate the molar mass of each of these elements. And because they're elements, you don't really have to calculate a molar mass. You can really easily go up to, you can simply just look at a periodic table. So let's have a look at the periodic table. And just have a look at, say, sodium. So sodium is right over here. And it might be a little small to see, but it's 22.9, so we can use 23. And so on. You can have a look at oxygen and then hydrogen. So always have a periodic table with you, and to just check up on the molar masses if you don't remember them. I sometimes remember the basic ones on the top of my head, but always good to have a periodic table with you. So we can find the number of moles because we have a mass. We have masses right over here, and we have the molar mass. We just saw that from the periodic table, so we can find the number of moles. So we can do that for each one of these elements. And so for let's say for the moles of sodium, and remember your basic formula. So the moles of sodium is the mass of sodium divided by the molar mass of sodium, right? So you can just write a little Na, just remind yourself. And in this case, we know the mass is 21.9 grams. and we're going to say 23 grams per mole, depending on the periodic table you're using, but this is good enough. So grams cancel out, and you should get about 0.95 moles. Alrighty. So similarly, we can work that out for carbon, hydrogen, and oxygen. So let's go through that. Moles of carbon, so which was mass of carbon divided by the molar mass of carbon, and so I think we had 45.7 grams divided by, let's just use 12.01. That's what most periodic tables use. Grams per mole as a molar mass. Again, grams cancel out, and you're left with 3.8 moles of carbon. So same thing for hydrogen. I'm not going to write the formula down again, so just, it's the mass of hydrogen, which is 1.9 grams, divided by the molar mass. So very simply, it's just 1 gram per mole. Again, grams cancel out, and you're left with 1.9 moles. And last but not the least, for oxygen, so the mass 30.5 grams divided by 16 grams per mole. So cancel out the grams, and oh, look at that, 1.9 moles. So we have the moles figured out, right? Got moles over here, and over here, and over here, and obviously that was the first one for sodium. So now what you want to do is find the smallest number out of all of them. So we have 0.95 moles here. What else do we have? We have 3.8, 1.9, 1.9. So obviously, very clearly, the smallest number is 0.95. I mean, that's pretty clear to see. So once you find the smallest number out of all of them, divide all the moles by the smallest number. So, and essentially you establish a ratio. So we're finding a ratio essentially. So for sodium, the ratio would be, well, because it's the smallest number itself, so it would just be 0.95 divided by 0.95, right? Which is simply 1. For carbon, it would be 3.8 divided by 0.95, which would give you roughly 4. And for hydrogen, it'd be 1.9 divided by 0.95, which is roughly 2. And same for oxygen, 1.9 divided by 0.95. Sorry for my handwriting there, it's getting a little bit ugly, but you get the point. So we have established a ratio, so it's 1 sodium to 4 carbons to 2 hydrogens to 2 oxygens. So that's your empirical formula right there, so we can write it down. So that's your basic empirical formula. And so we have 1 sodium, 4 carbons, 2 hydrogens, and 2 oxygens. So that is your empirical formula, right? But if we go back and look at the question was originally asking for the molecular formula. So we have one little more step to go. We know the empirical formula, so we can very easily find out the molar mass, determine the molar mass of the empirical formula. And again, this is easily done by just grabbing a periodic table. And so we have 1, so the molar mass of the empirical formula, oops, that's a little too big, would essentially be the molar mass of 1 sodium, so it's 23, plus 4 carbons, which we established was let's say 12. I'm just doing it like basic numbers, plus 2 hydrogens, and hydrogen is roughly 1 gram per mole, plus 2 oxygens, so roughly 16. Once you total this up, roughly get 105 grams per mole. So that's the molar mass of your empirical formula, just by looking at a periodic table and adding them up. So what you do, you take the molar mass of the empirical formula, and we'll just write that down so you don't forget. So take the molar mass of the molecular formula, and essentially just divide it by the molar mass of the empirical formula. So in this case, that would mean if we recall the molecular formulas, oops, a little too big again. The molecular formula, I'm just going to call it MF, had a molar mass of 210 grams per mole. And we had already established that. We just calculated it. This would be the empirical formula. So EF had a molar mass of 105 grams per mole. Obviously, grams per mole cancel out, and this gives you a 2. Now, what does this 2 stand for? Essentially, this is the ratio difference between the empirical formula and the molecular formula. So, what you have to do, you take your empirical formula and multiply it by the number determined above. So, which in our case is simply the number 2, right? So it's 2. So really easy. So our empirical formula was, let's recall, Na C4H2O2, and our molecular formula should be your empirical formula times 2, which would give you Na2 C8, oh, that's a really ugly 8, I'm sorry, C8H4 and O4. So basically that is how you find out molecular formulas. Very simple, and make sure you have a periodic table on hand because you're going to need it to calculate molar masses and whatnot. And essentially in any chemistry stoichiometry problem, just make sure you have a periodic table. You know, just you're doing chemistry, you're going to need the periodic table, trust me. Unless, you know, you've had these numbers memorized, but seriously, there's no point in memorizing them. You're going to be given a periodic table, hopefully. In high school, there's no chance that they'll make you memorize it. Depending on the university you go to, you know, some profs are a little bit like, oh, you're in chemistry, you should, you know, memorize the whole periodic table. This has happened to me, but there is no point in doing that. So because I pretty much forgot it, you know, it was like 2 years ago. So have a periodic table on you, and yeah, with practice, you will probably, you know, memorize like the basic ones like sodium, carbon, hydrogen. You're going to use them so much, you're going to know the molar masses like off the top of your head in a while. But so don't worry about that. But this is how you find molecular formulas, and you know, don't worry about this number right here, the molar mass of the molecular formula. You will always be given that. That is a given. Without this, you cannot do the question. So you will be given that value. So don't stress about it. If you're not given that value, you know, simply you can go up and ask your teacher or prof, whatever, like, you know, I can't do the question. It's not a typo. It's probably a typo if they haven't given it to you. It's not like they're trying to trick you. It's a mistake. You basically cannot do the question without that. But other than that, that's about it for this video, and see you guys next time.